Good evening, my dear subscribers and followers. In this video, I am going to discuss migration models and development. Let me start with the definition of migration. It is the movement of people from one place to another with an aim to settle permanently or temporarily at a new place. It can be within a country, and that is called internal migration, and the most notable one is rural-urban migration. Globally, rural to urban migration is the most dominant form of human migration. Migration can also be external, that is, migration from one country to another country. This movement often occurs over a long distance and is from one country to another country. This migration may be permanent, temporary or seasonal. It can be for reasons ranging from economic to social, political or environmental. Immigration is often associated with better human capital at both individual and household level, and with better access to migration networks facilitating a possible second move. Migration has a high potential to improve human development, and some studies confirm that migration is the most direct route out of poverty. So one of the way to reduce or to eliminate poverty is migration. Age is an important factor for both work and non-work migration. People may migrate as individuals or in family units or in large groups. There are four major forms of migration. People migrate because when one country invades the other country, or one country is conquered by another country, or migration may be due to colonization, or it may be emigration or immigration. In addition, pull and push factor also drive migration. Pull factors are those which attract people to migrate from one area to another area where there are some facilities, and push factors are those which are in the area of origin but that compel the people to migrate to some other area. Some people decide to migrate, for example, someone who moves to another country to improve their career opportunities, whereas some people are forced to migrate, for example, someone who moves due to famine or war. Migration impacts both people at place left behind and people at the place where the migrants settle. These impacts can be both positive and negative. Decisions about migration are caused by economic, social, environmental and cultural factors that I mentioned earlier. There are a number of migration models which formalize these determinants. These models may describe the effects of migration at its origin and destination and the interactions between those effects. Most migration models focus on economic determinants, and these economic determinants may include, for example, opportunities and constraints on income at migrant origins, for example, limited capital and technology, scarcity of employment, imperfect market environments, and so on. Another reason could be income opportunities at the migrant destination, where the demand for migrant labor in urban center is higher as compared to the demand for labor in the rural or informal sectors. There may also be migration costs that include travel costs, network of contacts at prospective migrant destinations, border policies, and so on. One of the most important models of migration is gravity model. There are a number of gravity models, and these models consider spatial mobility of population in analogy with Isaac Newton's law of gravitational, which was developed in 1687 as interaction between two territorial units, for example, countries, regions, etc. English scientist J.R. Stewart was the first to notice that this peculiarity, having stated the so-called gravity law of spatial interaction in 1941. And his equation is given by F, which is equal to K pi pj dij raised to the power -2. In this model, F is gravity or demographic force, K is a proportion coefficient, Pi is a population of the region of origin, I, Pj is the population of the region of destination, J, whereas Dij is a distance between interacting regions I and J. More generally, classical gravity model of migration can be represented as follows. That is, Mij is equal K Pi Pj Dij raised to the power negative of alpha, where the coefficient alpha is positive, that is greater than 0, and it reflects the friction associated with distance as K should be determined in the model. Generalized gravity model can be represented as follows. Mij K Pi raised to the power beta, Pj raised to the power gamma, Dij raised to the power negative of alpha, where beta, gamma and alpha are constants that reflect the relative weightings of the constituent variables. According to gravity model, migration Mig between place of origin I and the place of destination J is a positive function of reflexive forces at region I, and that is denoted by Ri, and attractive forces at region J, that is denoted by Aj, and is inversely related to the friction or distance between the area I and J, and that is denoted by Dij. And it can be given as Mij is the function of Ri Aj divided by G of D. So it is positively proportional to repulsive forces at the origin, the place of origin, and attractive forces at the place of destination, and it is inversely proportional to the friction or distance between the two regions. Lee in 1966 hypothesized that both the destination and the origin have characteristics which attract or repel migrants, and that perceptions of these characteristics differ between migrants. The complexity of migration models has increased as research has evolved to address these and other questions. Then there are some other models, and those were propounded by Lewis and Schultz. W. Arthur Lewis, 1946 dual economy model of economic development with unlimited supplies of labor was not an explicit model of migration, but it also showed that migration occurs from rural to urban because of the lower wages and unlimited supply of labor in the rural areas and higher wages in the urban manufacturing sector, due to which people migrate from rural or informal sector to modern urban and manufacturing sector. However, in this model, migration is the means by which surplus labor in the traditional agricultural sector is redeployed to fill rising modern urban sector labor demand. Migration is demand or employment driven rather than being driven by wages, which are assumed to be fixed. The Lewis model assumes that surplus labor exists in rural sector. Later on, Schultz in 1964 held the view that once migration eliminates rural labor surpluses, urban wages must rise to lure additional workers from the rural sector. Wages adjust to ensure that both rural and urban labor markets clear. This is the essence of the new classical migration models, which are of the form Mij is a function of Wi, that wages in the area of origin, wages, Wj are the wage rate at the area of destination, and C is the cost of migration. In new classical models, intersectoral wage differentials are the primary factors driving migration. Population and distance play a major role only insofar as they influence wages and are migration costs. Empirical models document that migrant flows are usually from low wage to high wage places and respond negatively to migration costs. It means if the wage differential between the two areas is greater, then there will be migration from the area or from the regions where there are lower wages to those areas or regions where there are high wages. But migration will be negatively impacted by the cost of migration. If cost of migration from area I is higher to area J, then in that case migration may be negatively affected. However, wage-driven migration models cannot explain migration in the context of high rates of urban unemployment and explain only a small share of variation in migrants' flow. Then we have Todaro's model of migration, and this theory explains rural-urban migration as an economically rational process despite high urban unemployment. Migrants calculate the present value of urban expected income or its equivalent and move if this exceeds average rural income. In Todaro 1969 model, the prospective migrants maximize their expected income in the aggregate migration equation given above. Wi and Wj are replaced by expected incomes at places I and place J respectively. Then we have Harris-Todaro model, an equilibrium version of the Todaro. This is the equilibrium version of the Todaro migration model that predicts that expected incomes will be equated across rural and urban sectors when taking into account informal sector activities and outright unemployment. Here is the interpretation of the Harris-Todaro model. In this figure, the demand for labor is given by marginal productivity of labor curve in the agriculture sector, and it is negatively sloped and given by the line A prime. A labor demand in modern sector is given by M prime, and that we may read from right to left. This is in the manufacturing sector. The total labor force is given by the line OM. In a new classical flexible wage full employment market economy, the equilibrium wage would be established at W star A, which is equal to W star M, with OA L star A workers in agriculture sector and OM L star M workers employed in urban manufacturing sector. All available workers are therefore employed. So this is a kind of new classical flexible wage full employment type of situation. But if urban wages are fixed as assumed by Todaro at a higher level, say W bar M, which is at a considerable distance above W star A, what happens then in that case? If for the moment we assume that there is no unemployment, OM LM workers would get urban jobs, and rest of the workers, that is OA LM, would have to settle for rural employment at wages OA double star below the free market level of OAWA star. So now we have an urban rural real wage gap of W bar M and WA double star, with W bar M institutionally fixed. If rural workers were free to migrate, then despite the availability of only OM LM jobs, they are willing to work. They are willing to take their chances in the urban job lottery. If there are chances of securing one of these favored jobs is expressed by the ratio of employment in manufacturing LM to the total urban labor pool LUS, then the expression WA LM divided by LUS W bar M shows the probability of urban job success necessary to equate